that is brought from allowing from Moldflow, or is it an equipment that will take out the process parameter that may be not optimized by the software, or both of them? So listen, when you interface, it is possible if you interface this to a machine that will be able to utilize geometry, those parameters, right? If you can interface it with the CNC mill, with the 5 axis, 7 axis, it will be able to cut out the geometry, like the depth, right? That's what geometry is, like the depth, length, EPC. Yes, let me do that.
So you don't understand my problem. I'm going to say if you can.
I didn't say you can.
No, you say if you can interface. That was one of your questions.
That is the interface. That is what we are talking about.
You say if you can.
Can we?
Can we?
We are supposed to design it in place. I get it. So, good afternoon, ladies and gentlemen. It's a pleasure having everybody on board. I guess we've already met each other and we know what this training is all about. For the sake of improvement or like on performance and record purpose, we are recording and starting recording, capturing this training workshop. So it's going to be like an interactive workshop that we will try hands-on, practically. We're going to hands-on Moldflow, Autodesk Moldflow, plastic injection software. Now we're going to do a lot of things. There's a presentation we are supposed to have, but for the purpose of the live, that is not available. That was the PowerPoint presentation, the PowerPoint presentation for tomorrow. If the light comes up, definitely we're going to have it. And besides that, after the presentation, we are going to advance to the software installation, because installing that software is a little bit complicated. It has hardware requirements and it has software requirements. Now let me talk about the hardware requirements. For your system, it is recommended that you have an i5 system. You need the second generation processor. Then your RAM was nothing less than 8 gigabytes. You can't upgrade this software with 4 gig. If you crash the system completely, because the software eats memory lots. So, and when you're working on the software, you ensure that you close, exit all other applications. Every application that you're working on your desktop must be closed. It must be only that software. Because by the time you are tweaking, you are seeing, it's a three-dimensional thing. When you install the software, you see how you're going to be using the mouse to click X, Y, and it has like X, Y axis. When you click this to flip, you see the three-dimension of the plastic, like this pattern, or any of the plastics around. You can see if you flip it in both front and back side, it has upper view, lower view, that's complete 360. No, 360-degree view. So that's what we're going to do today. And the slide comes, we're going to start with let me have a copy of that. A copy of the painting. Let me just flip to it. Yes, that's where I wrote the days and then the time. Yes, that's it. That's it. So, like if you see this material, the first one you have the introduction, just like what we're trying to do today. Then the second day, which is the 16th, you have the user interface tutorial. Then the third day, the 17th, we have new user quick start tutorial. Okay. Then on course, we have the meshing tutorial where we look at meshing models and how to tweak them and put variables for perceiving future production and performance. Then the field analysis for Friday, there is a model on ground that is part of what is copied onto your computers now. We're going to be testing field analysis on Friday. Then we'll have our weekend break. Then, followed by on Monday 22nd, we have the generating report tutorial. And we also have the processing tutorial for the 23rd. Then we have the export results to Autodesk, multi-communication tutorial. Then we also have the meshing editing tutorial. That meshing, let me talk about meshing. For those of you who know about SolidWorks, you will have been doing a lot of meshing. You know what meshing is. Meshing is a very, very common attribute that most of these simulation programs will have. And when you are doing meshing, it's more like a pre-analysis. There's analysis over here. Now, tomorrow, hopefully, because the someone I'm expecting that the man that printed this material for us has told him I'm coming back to print something. There's something I need to show you. Now, that thing I'm going to show you represents, just like when you have Microsoft Word. You have Microsoft Word that is in a linear form. You have everything, your menus like this. For Autodesk Moldflow injection plastic, your pin, your left-hand pin, is where you have your parts. The parts are there. Then you have your injection, where you place, just like when you click on the injection icon, and then you begin to pick places where you want to put the injection, it will appear. Are you getting it? That's part of the list. Then you also have the analysis tool there. That's that. Then another thing I want to draw your attention to is the geometry. There is a menu in the let's say horizontal menu of this software that you have copied down. It's called geometry. That geometry is where you actually put the variables. There are input boxes where you can simulate maybe volumes, lengths, all these other variables that you use in the production process. You can put it there to suit what you want to simulate. And when you now run it, it will now show you what it will be in real time. Now, let me tell you something. There's a difference between simulation and virtual reality. Okay? Now, they are very close. They are both softwares. Today we talk about digital twins. Digital twins, please, you can write that down. Digital twins. If you have a Bible here. Digital twins. Now, digital twins in technology represents the best explanation I can give to it is an autonomous vehicle. Tesla. You see Tesla, this Tesla they are testing in the US and China and other countries. A driver, might be in the office, right here as we are now, and will be remotely connected through a computer network and all that to the mainframe of the system. So the driver that is in the office now with the communication gadgets and all that, you will now begin, you handle the steering as if it's there. You ignite it, the car will start and will start moving. Now, what we're saying in essence is that all the controls in that physical car somewhere down there is already on that position where that particular person is that is controlling the autonomous vehicle. What I'm trying to say is this. You see, simulation is just like that too. You are going to be the one in the office. You are the one that is going to determine, you will have drawn your schematic, just like you have in electrical engineering. You will have drawn your schematic because you know what you want. You get it, everything is here, or probably written in a piece of paper somewhere. So when you have that in mind, you will now go back to the drawing board. That geometry menu, when you bring it out, you now begin to put there's a menu there you put that you see those variables. You now begin to test them. You can test 2, 2, 3, 4, 4, 5, this, that. And when you put it, you now click and then it goes into the model flow. The model flow will now adjust to it. It will adjust to it and then it will now simulate it. You now see the actual, then it will also, then the results there's a menu. After you have done the simulation, it will now give you a result. So what I'm trying to say is that Moldflow is a simulation software and is similar to digital twins. Because digital twins actually represents some sort of physical and virtual interaction of instruments. Where you have a car outside and you have a twin of it in another place that someone is controlling. This is where technology is going. Let's pray before Jesus comes back and will not end the world. Those kind of things. That we will live long and we'll see our children's children. In Jesus' name. Who will give us the only prayer? Who is the pastor here?
Pastor Chile.
My action of the question.
After the prayer.
Let's pray. The question now is this.
Like this Moldflow of time, so after what you said now, it also works with some operating parameters like pressure, injection pressure, the melting temperature of your resin, which are the polymer material now that you're going to export. Then your cycle time. Policy work with it, cycle time of feeding, it will meant in the plastic unit before it will not be feeding, the clamping, injection. I get it now. So Moldflow is like a virtual replication of injection molding process in the factory.
Now we done that. What is his question? Excuse me. What he said is this: have you done that on your system?
Yes.
How do you get that your mode in the physical? Our machine now, because he just what he said when you listen to him, he said that the man said I5 less than I5 computer with or I5.
Okay,
so do we have machines now that can match interface? Compatibility.
An injection molding or extrusion molding machine that can interface with the It is the injection molding and extrusion molding plastic machine that the CNC can accept this Moldflow information that will produce. As lead, can we acquire? Can we acquire the plastic?
We have.
No, but the question is do we have?
We have.
To the best of our knowledge, do we have? Let me answer. We don't have.
No, machine. I use EDM now.
So that do we have any plastic molding machine?
There are many interfacing where you have the process parameters, right? Like operating temperature is the process parameter.
No, we're talking about hardware. It's hardware that we're talking about. I'm listening.
No, you say you want a machine, right? So I look at the argument.
You're talking about variables. You're talking about intangible variables.
particularly for the localities. What I just need to know is that do we have a machine that can match what we are learning? It's straightforward.
Sorry, sir. Sorry, sir.
In our normal CNC, we discovered that definitely we need upgrading. Upgrade is part of the process. Then he's coming out with a very high-tech software that everything about the software is of high profile, going by what you need to install right now. So I just need to know if we have what matches this.
The first thing we have to do, I want to understand, the first thing we have to do, what are the products, what are the results that come out from Moldflow?
It depends on the...
No.
Wait.
First. It is what
Your mode, geometry, product that can come out from your this thing.
can geometry come out?
Yes.
Your mode, that's what will come out from it.
This thing has the geometry.
Use steps.
This thing has geometry.
Wait, somebody say.
Wait now. Can geometry come out of Moldflow? Geometry come out.
Wait, when you are saying geometry, all of us might not understand geometry.
Okay, look at what I mean.
Look at it. They see
That's what I
that
mean by geometry.
as long as you have your phone product, it can come out. No, don't go by that.
Okay,
As long as you have the mode for your product, that product will come out.
So what I'm asking is that Moldflow can produce geometry.
Agree.
Can it also produce process and then optimize or the right process parameter in molding? Like what are these? What are these process parameters?
Even the pressure,
You may not tell me why you were addressing this.
So if you just put down.
Wait.
So these are the outputs. These are the outputs of Moldflow. Geometry of mold, which is dimension. Optimize process parameter, which will give the molding process effectiveness and optimize the values of operation. So now,
This man is going to be our captain, our class captain.
now, listen now. So what equipment are we talking about that we use to connect to the system? Is it an equipment that will produce geometry that is gotten from an output from the Moldflow, or is it an equipment that will take out the process parameter that we got optimized value in the software, or both of them? So listen, when you interface, it is possible if you interface this to a machine that will be able to utilize geometry, those parameters both are geometry, right? If you can interface it with a CNC mill, maybe 5 axes, 7 axes, it will be able to cut out the geometry, those geometry, like the depth, right? That's what geometry is, like depth, length, etc. Yes, I'll give you that.
But you don't understand my problem. Now people say if you can.
I didn't say you can.
No, you say if you can interface. That was one of your questions.
That is the interface. That is what we are talking about.
If you can. You say if you can.
Can we?
Can we?
Is it already there? It is there. This is not a generator.
On a good day, what we are going to do, if we must get it right, we are supposed to design a mode first. Are you getting it? When we design a mode, I don't want to design a mode for this. We are supposed to design that mode for this. Then import that mode to this Autodesk Moldflow. Run the optimization.
No, design it to where?
Well, why do you design the mode? Wait, no. I know what I'm saying. That's not design. He's drafting. There are different CAs now. Say you are drafting first. When I do that, I'll send that to you. I'll import it to Autodesk. Yes. Here, I will check if my node design is correct. Yes. I guess now, if that model that I've designed using Moldflow to optimize is correct, I cannot send that mode design to Owolabi to produce the code for me. So and you can also do something. You can also do something. Since operating parameters, process parameters, optimized process parameters like temperature has been ascertained from your input analysis. You see, you can actually, if you have a machine, this time you have a plastic injection machine. Now, that plastic is not only that, see, just relax. You see, wait, let him talk because you see, you must have for that way. But that's operating parameters. If you want to have a successful moving process, see, there's one thing to build a move. You will use what you have said, Autodesk. The physical card is where.
That is a simple question.
See,
that is a simple question.
You need to understand how files convert the information of files. For processes, there is one form to for example, if you use a software file to control a machine, right? It must be converted into a format. For example, you hear about step files. You hear about files that are STL, stereolithography files. You hear that. You've also heard about CAD files, right? Like the one like D.DWG. You see, those things are, for example, let me tell you, when you bring in your CAD, you draw there, right? Now you will save it, right? If you save it in .stl format, that file is readable by a printing machine, a rapid prototyping machine. You can read it. But if you save it as a .dwg, it will not be read by the printing machine. Now, if you save it as STL, it means that already a software converter has turned that CAD file into a machine movement or something that can control a machine. You see? And so that STL file will be further converted by a slicer. It's what we call a slicer. It's a software. What is a software? It's a slicing software. What it will do is it will convert the STL format that you have put there to G-code. G-code will turn your module. You see? It's a G-code. STL .dwg cannot turn the module. But G-code, yes. What's it called? It's a slicing software will make your module turn 70 times or 1 time. You see that? So when you say whether this software can be able to do that, it may not be able to do that. It may produce a .dwg or a .stl format, which can be further converted in a system, right? To be that software.
Sorry to cut you. In addition to what you say, now, what software, this particular software we're installing, is 2023 version. 2023 version has some special attributes, like what you have mentioned. Now, files, extended file with file extension, DWG, the one for AutoCAD, blah, blah, you already have. So you can modify it. That's why they are called models. You can modify it. Your assignment as a plastic engineer is to know how to place these variables. Like these people are writing nation. I'm so happy they are. I've started picking out engineer Mike, him, their team. I've picked out these 3 people now, these 4 people now. It's like they know something, they have an idea about this thing. So this will help as we progress. Because they can, instead of putting the whole body on just one person to explain everything, might use words that you don't understand. When others come in again, you use standard words and you get to understand. I believe that the question has been satisfied.
Of course.
So any question, someone else wants to ask a question. Contribution.
Hello. Actually, what I wanted to draw our attention to, that's why the final evidence show. I want to draw that we are here not as novice, because we know where we come from. So let's not put it to ourselves. Let's not also think that we know it all. We give you a chance because we already have us in the center of the right. So, in our questions that we want to meet for us, when you want to finish so I want to be with us. Let's focus on what we can maximally get what we need to get from our Lord. And then what we have to do, of course, we will agree with you that among all the softwares we are doing training on, we cannot exhaust it on one training. It's mainly when you finish, you are now really begin to explore that. For instance, you might even begin to use it more than the person that talks to you. Before now, I'm asking a question, a practical application of what we're doing. Is it really using real? Is there any policy that is already using it?
It was a problem on ground. That's thing I've been trying. So you are saying that you just what you just saying that you are just bringing advice and also bringing something that are not necessary. So which one is it? Because you answer the question, what I'm done with that. So the question now is not what you just saying like this advice. No now. It's observation. What is that observation?
Let's be more organized for we have somebody on ground and completely organized. The rest is whoever that pass the stage. So allow the person to initially be something foolish because these things have to have so it won't look like as we gave me out the corner. Please.
As at 2023, Moldflow advisor, I think, if I'm not mistaken, has been integrated into Ultimate. That's why it's called Ultimate. We have the earlier, we have premium, we have this, we have that. But this time around, everything has been compressed into just one. So when you're installing, you're going to see a series of them. The communicator is there too. Because previously it used to be separate. So the advisor, I think the advisor now, if I'm not mistaken, has import it to Microsoft Corel. Yes, Corel can take it, PDF can take it, looks like that. So yeah, it's calculated. Any other question or contribution?
Based on your last answer to my question you asked, the operational system yes, this time around is a different problem, right?
It's a different ballgame, sir.
So that is what I want to clarify because it's going to be different.
It's a different ballgame. The recommended system, like I said, like for instance now, this is an i7 system. Maybe after this one, you guys are recommending you to get anything from i5 4th generation up. Someone recently that telling me his PhD in computer science, contacted his friend, he's a lecturer in the University of Alabama. His name is Aaron. He sent me 200 short. I have customized the system. You can't find it in the market. I went to the market, bought the parts, put it together, 2 terabytes of hard disk, 4th generation i5 processor, keyboard lights, 16 gig RAM. Then I now split the hard drive, I divided the hard drive into 2. One partition contained the Microsoft operating system, 1 terabyte. The other 1 terabyte contained what we call Kali Linux. Kali Linux is a software used for security, for cyber crime, tracking of cyber crime, and detection and all that. Like stuff, because it's doing forensics. So I would recommend if your system doesn't put it up to i5, if it can manage to install, thank God, because most of them, the issues is that Moldflow have when you install it, it's 1603. You can check it, I wrote about it and I also talked about it in my video there. It has a specific error, and that error, what it gives it, the main problem will be the hardware, either your processor or your RAM is not insufficient or something, you just keep hanging. Keep going to error behind it. What we wait for is that once we have the ability to go live with the power source, or the power source that is not really technical issue. So what I intend to do today is that we're supposed to install it on all the systems and now see the results. We want to install it on all the systems. This Moldflow detection classification software. We want to do it, we want to install it. It's there. We've copied it now. It's on all the systems. So we're going to install it, then test run it. I want to run all the exercises one by one. Everybody will run it. You tweak it, see how the plastic is, the injection level, the particular level is the geometry. What I want the engineer to say that the geometry. Because I think they have, you guys used something more before. And mine too. So it's similar, but you know that this is more focused on plastics. Maybe, but if you have an idea for other software, it will help you. It will help you a lot. And it can also help others. Other engineers here.
Suppose that guys were a little bit on hand.
So my name is I work in a department that is so much interested in the
us and make money. So it's still going to always about abolition and independence. Are we going to get it from this training? That's because I'm asking you.
Okay. So as far as that is concerned, now that is now up to you because this now that is now up to you because this 10 days.
The concept of
They are also having problems with efficiency in molding the molding process. Sometimes the depth, the thickness of your molded plastic, right, can be the definition of whether you will live profit or not. If your mold thickness, if your plastic molded product thickness is too much, you know what that means? That means too much material. Money. But if your thickness is too light, you also have problems. One of the problems is that thin sections will deform, even in the process of the molding. Your thin sections they will deform, and then thin sections also cause something. The flow may not be complete. You see, because in a block, even if it's a thin section, it means that the space for fluid is also thin, for fluid movement in the block. So you may have issues in flowing. So if you know this very well, you know it very well, you can consult with them, right? Sometimes too, if you can optimize, think about that. If you can optimize and you get particular values, for example, the dimension of the runner that is right. By the time they start talking about problems, you bring in their mold, right? You model that their mold, right? And then you measure their own. You will see discrepancy between your channel and their channel. Probably their channel has already eroded, so it is now bigger. If you understand what I mean, or it is cracked. There's a gate that is cracked. You see, what you have done now, you see that this is the ideal. This is what it should be. Their own is what it is. So you can correct their own. If you have capacity for correcting them, you can correct with the features that you design for. So you understand what I mean? Yes. Then again, so just to add to what he's saying, the purpose of plastic Moldflow is to reduce operational costs. Yes. Just like what he has said, operational costs. Why produce something in huge industrial quantity, inventory? Why produce them in huge quantities when there is a defect? Why not see the defect before the production and to save the cost of the producing? That's the real, and what can help you that is your knowledge of the software.
Since we are playing the operational it means that it's one of the research that so I started the consultant. We are playing the operational parameters. Since we talk about the event, what I said is that I said since we are playing with the operational parameters, it means it can also be used for sort of research analysis. Yes. Aside from the consultant. Exactly. Yes, of course, yes. There are a lot of
projects.
Exactly, yeah. A lot of papers. This thing is an academic software, apart from being an industrial one. People use it for a lot of research. Tests run certain movements. There are millions of classes, millions of them that are out there.
So you play as a let's use for flat measure, what
exactly, yes. Like metallurgical engineers, mechanical engineers that are into the academic, they do that just for industrial people to use. So once they meet their statistics, usually use machine learning now, AI, once they meet their findings, they publish their results. So it means that you can also go into that field apart from those industrial application developers.
Yes, so many
small production that we did inside this environment that where it is. Because it is not just.
I think we should be. If there's ever, is there any other thing again? Because I don't want us to.
Okay.
I don't want to. We already have this presentation in your files, part of the material we're going to study. Now the slides are just about 22 or so. There's not much. Quickly run through it. This is the introduction like the front page. It says plastic injection and compression mold simulation for design and manufacturing. An overview of Autodesk Moldflow insights. Okay, so now let's just move to the next slide. Now it says here that what is Moldflow? Moldflow simulation software lets you troubleshoot problems with plastic injection and compression molding. Advanced tools and a simplified user interface help you address manufacturing challenges such as part warpage, cooling channel efficiency, and cycle time reduction. Okay, so with that, we move on to the next slide. Now let's go to the user interface. I'm going to be giving you a material of user interface much later. But this is what the user interface looks like. Now, yesterday, you will recall while we were discussing, we were having an interactive session. I did tell you that the interface to the left, the one you're seeing here, where the project is, that thing you are seeing up there is where all your major files will be arranged. And this software, this Moldflow Insight software, particularly focuses on the import menu. Because most of the plastics we have already have models. Okay, now let me talk much more in detail about models. When we talk about models in computing science, we talk about we can call them like systems, pre-built systems that, okay, we all know that 1 plus 1 is 2, right? So if 1 plus 1 is 2 in any language, you don't need to produce another 1 plus 1 again. The only thing is that you can use different things to demonstrate 1 plus 1 to be 2, right? So the same thing applies to this. You see, models are standards that are built so that you will not have to reinvent the wheel. You will not have to start all over from scratch to build something. You can use existing models. Another example is cars. Toyota has Jeeps. There is Prado Jeep, there is SUV Jeep, there is that, different brands of Jeep. It just took one person to produce a Jeep, and everybody started throwing the model, and maybe adding a few things to it to improve it. Are you getting it? So that's exactly what models do. Models, they have mathematical implication because, of course, they are built with engineering principles. Okay, so the basis of a model is building something that can be reused. In computer science, we talk about object-oriented programming. One of the attributes of object-oriented programming is, carrying tasks. If there is a task to open a door, another programmer coming in next generation doesn't need to write it again. He will build it and put it in a library. That's why all these computers you see around you, they all have libraries. They are libraries. They have libraries that are built, okay, to perform certain tasks like shutdown menu, restart. A programmer doesn't need to do that. All you need to do is just inherit the existing class that has all those functions of shutdown, restart, and then begin to use it. When he's building his own program, like this Moldflow now, this Moldflow we all use now, has an embedded code called OS allows you to browse within the program without going to Chrome or Firefox. You see? So that way is a typical example of a model for browsing. That's a browser for internet functionality. It's functioning as a browser for the internet. But here, in this respect now, in this engineering class, this workshop we're having now, we are focusing on the plastic category, plastic aspect of engineering, where you have models for this bottled water you all have on your desks. So if you want to probably make a few changes, you can tweak it, you can maybe the length, reduce it or something, but the model is there for you to use. So it is now left to your initiative to add value to the existing models. And that is where you engineers come in, the new generation of engineers. We are expected to continue from where others have what stopped. Let's get back to the screen. So there, across the board there, is where the project pane is. Now I also mentioned to you yesterday, if you recall, that particular pane there contains the injection model too. The injection model, what you use to injection model first is there. Then the parts, the geometry, the analysis, perhaps the results too, is also there. That's happening there. Then here, beneath it you have the story tasks. You can see the story tasks there. Those ones are just things to support that major project. Because the main one is that upper one that you see at the project. Now, beneath that you have layers. These layers also are interdependent. They work alongside the project, the main project there. Then, over here, coming over here, you can see the environment toolbar. Now, this environment toolbar is also very important. The one I described yesterday as horizontal. It contains the geometry. The geometry is one of the most important aspects for you as an engineer to get used to. Okay? But we will not be going deep into geometry in this workshop. We will not. What we're going to do is that we're going to be like going into some sort of overview. Prior to the time because right now some of us are still struggling with getting used to the software. So we're not going to go deep into that one. We will be going into how you can use the menus to turn, to twist, to do your 3D, then get used to the menus. So that you can, in the next workshop we'll be coming for, which of course we will definitely have, those of us that really show very good signs of being engineers, plastic engineers and consultants in that field. We now return back for a match for much more advanced analysis and design. So that is that. So geometry is one of the most important menu there that you're going to be encountering. Then what else there? They also have the results tab there. This thing environment is very rich. That's the results, the analysis, and some other things there. One of the most important parts you see in this project is the injection. The injection tool, once you click it, it will show you, you can position them as matrices or vertices. You get it? A layperson cannot operate this system. This software is not just for people. It's for people who are engineers. That's long story short. It's a very, very dedicated software that is used for industrial use. So if you don't have any business with it, look at the time it has taken for you to install. And it's selective. It's an intelligent software. It's selective of the kind of hardware that is going to install itself on. So it will read, as it's trying to install on your system, it will read, as we're installing a trial version, it will read the components of your system. It will read your RAM. If your RAM is not 8 gigabytes, it will refuse it. If your hard disk space is 40 or you have part sectors, it will refuse it. It will not go through, it will hitch in an error. It will show an error. So that is that. Let's quickly move to the next slide. So this is the same thing. And now, let me talk quickly about this. Now, these are the CAD files accepted by Moldflow. Excuse me, let me check that one seriously. I want to go through this aspect and we are going to inspect it. That's why I use this thing. Here. Okay. Still on.
I don't know Ejike.
I'm going to do it amongst tasking. We don't need to camera and doing everything. So that's us as engineers. We don't need to complain. And so much, that's why one of those things I like about engineering. As an engineer, you don't complain about anything, do the work, deliver. As it is that at home, look at what Mr. Sheidu did now. We had a problem with this extension. He quickly, without anybody telling him, get the screwdriver, and it's done. So So we must be open to learn from each other. Because some of us are very, very bossy. As engineers, we want to prove, say, we know, yes, we know, but we can still learn. Even me too, as I am today, at least I learn. I'm still learning. I don't know it all. No one knows it all. So we must be able to learn from each other. So where did we stop? Where will the real line be? Are there air drops? How deep should the path be? These are research questions. You see, this software is apart from me having an industrial application. These are research questions. A lot of professors use this thing to research. So if the flow within the path balance, are the ribs too thin to fill? Are the ribs too thick? Can the path be molded enough? Will the stuff fit? Is the press big enough? Are the runners balanced? What size should the runners be? Can the runner volume be smaller? Is the gate the right size? Is the cooling uniform? Will the path wrap within tolerance? These are intelligent questions as a practical may be answered per issue, per model, per development, per plastic design. So brace yourself up and ensure that you're ready to do this. Now, today's agenda, not necessarily today, generally, what we face. Analysis sequences, setting up to analysis via results, tips and tricks. Design analysis sequence. Now, this thoroughly shows some of those things that this software is going to do. The design advisor, the engineer Chidozie.
Chidozie.
No. She was mentioning asking something yesterday. I forgot whether advisor or no advisor. I told you, what did I say? You remember? Everything happened today. That was for all teammates. So that the design advisor is there. Give location, moving field, owner advisor, owner balance, cooling quality, field plus pack, rack, cool, sync man, and these are basic attributes, functionalities that this software has, is going to be doing. Okay? So, go on. Meshing. I talked about meshing yesterday. Meshing too, we do the whole lot of that. You have to do all the Micheal, 3D solid, deep wall parts. Now, those that are not SolidWorks, there is a way you can integrate your work in SolidWorks into this particular software. We're getting to know complex geometry, talk about geometry. Geometry is one of the easy tools to use to do a lot of manipulation. Here, mesh control, accuracy setting, so on, and so on. So now, here, the setting up is you can do a whole, there's part only, there's single cavity, there's multi-cavity, and then there are others. Now, the process for the setup, set analysis start and apply injection depletion. That injection depletion, before we finish this course, we're going to see, how to do that. So you can see it is a sort of screenshot of this. Welcome, sir. Are you just joining us? Okay, so what I said was very exposed. Oh, sorry about that. How are you feeling today, sir? So, grade out, deep part only. Now, sometimes you might not see, if you don't see it highlighted like this, this is specific focus on geometry. You can see out, you can see no type. This is geometry. Translate, indicate, mirror, set pattern plane, both sides, runner plane, runner wizard, runner, screw, gate, field system, cooling system. You see, these are all the modules that exist in geometry that you can manipulate as an engineer. So you have the specifics. You know what you want to do on paper. You have done some rough work and know what you want. Then use these things to input value and fire up. Okay? So let's go to the mode creation. Orientation is very important. Yes, orientation. That's why for this, most of this thing that we are having will be me. I want to be. I'll be putting you guys through at least getting used to the interface. You know, feel comfortable rotating, maybe trying things, even if you run into a problem, it doesn't matter, it's part of the daily process. Okay? So don't feel bad that you're not getting something yet. So give it time. Right? By time, give it a little bit of period where you like move forward and make progress. So these are field coding systems or mode where the pattern determines. Now, orientation is very important. The XY plane for the surface area, yes. This thing, so you see X, Y, and Z is what gives 360. You know, because you're able to flip, the system, the model, and see how it looks, side view, up view, 360. That's what does that. Pattern line determines exact many properties, use properties, dialog, specify what it is. So use wizards, normal imports. These are tips that you can use while you're operating software. Now, custom databases. Now, one of the basic things you find out in this group is this is the insights. The insights is the one that does the simulation when you're done designing your model. So here you can see that it has database. So there are millions of plastics from all over the world that have been integrated here. You don't need to go and start looking for your own. You just bring it up from the database. These points you are seeing here, these are icons for databases. So you just call it up, you can see here, there was plastics injection molding software parameters, defaults. Thermoplastics injection molding software parameters. Thermoplastic is a company, right? Oh, you know Thermoplastic is a company. That's the company that does thermoplastics. How many thermoplastics do you have here? How many? You might have that. How many specifically? How many specialists in those fields do you have? The one in Agbadua, how many are there? So what I'm saying is that see, the need and the use of you as plastic engineers is far reaching. So these are some existing universal thermoplastic designs stored in the database. When you drop it down, you show you see the long list there. That's a long list of different models there that you can easily bring up. Both the one in existence and the ones that are yet to be fully in existence. So now, the Synergy customization. This is Synergy. This Synergy is also part of the program, the Ultimate. Synergy API. Synergy API is an object linking and embedding. ONE. I mentioned it earlier when we started. Object linking and embedding. This is something that brings internet connectivity into the brain of your work. Right? And also a programming interface. And people say that automated, like connecting to the cloud to check existing models, optimal values, and all that. So API supports different programming approaches. Visual Basic, VBS, VA scripts, and other programming languages. Visual Basic for application, VBA, as part of the Microsoft Office application suite. Visual Basic VB, title. The functionality of the API has certain known limitations. So functionalities are intentionally locked out as material benefits access. Some functionalities can be used as script, so they are not captured by macro. Reverse engineering through examples provided with signage. Examples are these, usually in the command prompts there, in custom reports. So you have the Autodesk Moldflow 2023. What is new? I need you to look at it closely because this very aspect is very, very important. You can see what is new here. Now you have the context input, impact rather. Then it's easier to manage and install processes, combine installers with Moldflow advisor and Moldflow product to install all components at once. So we don't really need advisors to develop communicator and different installation and software.
Okay, this one is not.
An existing model, you are only going to give improvements to it as a classic engineer are not doing anything new, as in, they're just adding value to the existing models. And it's quite another intuitive thing. You get it? So once you're not doing it, just a little effort from your part, go, you're on your way, you're doing something. You're saving companies millions of dollars, thousands of naira, whatever it is they are using. Okay? I'm an engineer. I have to talk about that.
I'm hearing millions of dollars.
Yes, yes. It's $1 billion investment. So, set analysis sequence, assign card body, set injection rotation, and other body condition of card. Suitable for auto mesh analysis. Now, this one is the conditional. This thing you're seeing here is the conditional. Alright? You say the conditional, you see, this look for mesh analysis. N represents no. So if it is no, manually, yes. Then, if it is yes, it goes down. Select material, set process condition, click and start analysis, complete analysis complete. Again, that's another condition. In conditional. In programming, conditional decide, they decide left or right. Boolean. Boolean in mathematics. This is the application that we're seeing. This is like a short after. So view results at the end. That's what you see in the information. That's why we're recording this video. So we're going to play back this video. I'm sending it, I'm preparing it. I called the Aaron-Orsu. I mentioned, do you know Aaron-Orsu? How many of you know Aaron-Orsu? Okay, Aaron-Orsu is the PA to Dr. Ejike. But I updated him on what he did yesterday. And it was quite happy. Yes. So we had to thank God. So that's that. So let's really move on. So this one, so this is the final slide now. You can see these are all the references I have. The ones I printed yesterday and I handed over to you guys. So you can see the introduction to plastic mold design is 67, 62 pages. Autodesk simulation Moldflow plastic design is 10 pages. They are all with you. I didn't print them all. I had to make abstract. I did abstract because you know, of course, it was too expensive. And then probably one of the people that afford this one to bring up what's the black white. I gave it to thank God for bringing it so far. This is the engineering thermoplastics design, 292 pages. The soft copy is with you. So you read them all. Simulation design for plastic injection. A mold drawing rule for credit card USB holder by Samsung 10 counts. That's 3 pages. Injection molding handbook, third edition. This is 1,483 pages, one of the biggest books you have in your collection right now. It's part of what you're doing with. It's already in the PDF, am I right? It's there. In case for those of you that have gone through it, it's there at 1,483 pages. You're not going to go read through everything, but just glance. There's a way you can read 2,000 words in just hours. Let's put it aside. If you are looking what you are doing, if you are an intelligent person, you don't need to read everything. Just most of the time, in a primary school, don't go with the primary school, when teacher, when you are doing summary, you know, the first line or two lines summarizes something in the whole chapter. The rest is just repetition. They are trying to explain. They are trying to do this. So this one for the way you go down, the way you just 50 pages. But we bother you to read what you need. So don't be afraid when you see me like this. And besides, I would have been able to bring this as material to you guys because it's too much. So make sure that really go to that answer. It's huge to just be brave. But each of them, like the contents of some of them are in your black and white. People are more than so intelligent organization of mold design and process materials in injection mold. That's 159 pages. Moldflow design guide, resource for plastic engineers. This one is very, very good. It's number 7. It's also in the PDF, so the PDF information. Very, very nice by the K. Shoemaker, Moldflow Corporation, Farmington, Massachusetts, United States. Yeah. We also have plastic injection mold design, construction for developer by Douglas. Plastic light injection mold Clemson, and runner and beating design tools for successful injection mold pages. So that summarizes our presentation. Thank you very much. So what I'm going to do right now is that we're going to move to